Now I will proceed to demonstrate I will tell you my non-secrets because they're not mine, and they're not Plato's, and they're not they don't belong to Pythagoras's. They're there. They're there. So what, by what right? Quid juris, dear Kant. Quid juris, by what right? Could I keep it to myself? Okay. I'm not going to discuss theory right now because I'll just I'll just start talking. I'm just going to say what I'm doing, and that's what I'm doing. Okay, so this is, I wish you could, it's, okay, key pieces of gear for gearheads. In order of importance. How about that? Dope for A143-9 QLFO, voltage controlled quadrature LFO. That gets you 360 degrees circle. You have a sine wave. Output from quite low till, I don't know, 3K something, 3,500 hertz. Just a sine wave. There's 4 copies. Number 1 is at 0 degrees. Number 2 is at 90 degrees. Number 3 is at 180 degrees. And the 4th is at 270 degrees. 270 degrees gets you the circle. So sine and cosine, it's a pair of sines and cosines. So the cosine is just offset by 90 degrees from its sine wave. So if you modulate any old parameter input with sine and cosine, you get a positive and negative oscillation of the LFO. That I will plug into a Pamela's new workout. The Pamela's new workout has 8 channels. Each channel has a sine wave. Each channel, and it's at one cycle, 1 hertz. The sine wave has to be distributed however many phase offsets. Now I've chosen to divide it into 16. Not 4 like the quadrature LFO. 16 analogous LFOs to that quadrature LFO. It's the same principle. Now there's 16. So there's 2 Pamela's new workout modules, 8 channels between them, 16 phase offsets, around 360. So the Quadrature LFO first pair, sine and cosine, I put to the clock input of Pamela's new workout 1. See where it's going? And the sine cosine output second pair from the quad LFO to the clock input of Pamela's new workout 2. I don't know if you can, yeah, you can see the lights. Now the lights are going in sync with the LFO, which is running at, I don't know, it's the knobs are up 12 o'clock, and the 2 knobs that we're talking about, there's a frequency knob 1 to 10, and there are 2 CV inputs. One CV input also is attached to a polar knob, so you get -5 on one side and +5 on the other side. So the quad LFO is the master clock. But the master clock, it has no tempo other than what you can feel or what you can count. And the reasons for this are mathematical and philosophical. And you know, all I take myself to be doing right now is describing what it is, giving the demonstration. I'll leave the philosophy to you. Now that really accounts for events for the most part, but it's not only events, because all of the rhythms and the tones, all of the partials, as it were, because every partial has its own rhythm and its own tone. Right? It's just a matter of what frequency it's oscillating at. So at once, we're generating all of the rhythmic events, all of the percussion, all of the expressive percussion, and all of the tone. Any harmonic frequencies, any pure tones, this is all being generated by one circular LFO outputting 2 mutually inverted oscillations of itself, or representations of its oscillation. One pair goes to Pamela's new workout 1, one pair goes to Pamela's new workout 2. So both the ALM, Pamela's new workout units, are inverted. Their polarity inverted. They're both oscillating. It's just that the polarities are switched. Okay, so now, and if I were a better podcast dork, I'd have all kinds of video screens to show, but you just have to take my word for it, including the waveforms on the screen, which is, quite a lot of the fun. So now I'm taking out of each row, so it's one of the first unit, one of the second unit, 5 of the first unit, 5 of the second unit. So beats 1 and 5, in other words, roughly. But we're not dealing in beats. Really, we're dealing in quadrants. Well, I mean, yeah. If it's a 4 beat measure, then it's intuitive. It's just the only difference is dialing in 4 beats on a 909. They're just fixed in one place. But here, because the phase can be shifted in various ways, the 4 beats may land anywhere on the 360-degree circle. Yeah. Pythagoras, huh? Okay, so we're taking the beats 1 and 5, as I've been calling them misleadingly, beats 1 and 5, channels 1 and 5, out of both Pamela units. Okay, the next step is there are 2 Worng, that's WORNG, Worng units, L, R, M, S, M, S, L, R. What these units do, they take a stereo pair, they tap what's in common and what's in the difference between them, and it taps those as M and S. So I'm taking one of each. One of each of those 4 outputs from the Pamela's units. So there's 4 outputs, there's 2 left and right pairs. Now, out of those left and right pairs, I'm only going to take the difference from both. So we've got 2 pairs. Each signal of those pairs is its own identity. It's separate. It's going to be some slightly phase offset sine wave from the Pamela's units. So those are going into the left-right pairs of the Worng units, and then I'm taking only the differences of both. So now I have this as a pair, and it's a pair of the differences. Now, each of these, one will go to Doepfer wave multiplier A137-2. Voltage controlled wave multiplier. 4 copies, 4 phase shifted copies of whatever's at the input. Right? The other one is the Doepfer A137-1 wave multiplier 1. That is harmonics. It's got a folding frequency, which makes the whole thing crunch and fold, kind of smash into a wall. You've got harmonics and you've got multiples of harmonics, continuous knobs. Right? It's just a few steps, but getting there took a few decades. Out of each wave multiplier, now because those alternate, because they're inverted copies, we will just stack it on the 5-volt input of Make Noise STO oscillator. So the only thing that will be happening is pitch changes. No other, yeah, from the oscillator itself, because the oscillator has a couple of other parameters. And I haven't tried this patch before. It's just kind of a variation of the stuff that I've been experimenting with. So, we shall see. All right, I'll put the oscillator at 12 o'clock. Okay, so both the wave multipliers are not modulating anything yet. And what kind of modulation? Nothing. No modulation yet. Literally. And there's nothing at the sync jack of the oscillator either. This is just straight up. The output from the STO and both those signals that are running rhythmically opposite one another, those are stacked at the pitch input.